Morning, everybody. Thanks for coming here to this presentation. I hope you're excited about Micronaut after the awesome presentation from Graham yesterday. We're very excited to present about this new framework we've created. I'll give you an overview of several things of the framework to give you an idea of how things works. Relax, fasten your seatbelts, and enjoy the flight. A little bit about me. My name is Álvaro Sánchez. I'm a developer since 2001. I used to create my own company, Salenda. I've been a Grails user since 0.4, so that's probably more than 10 years. And I got the pleasure to work for OCI, which is the home to Grails. And since yesterday, it's also the home to Micronaut, so that's awesome. And as a personal note, 9 months ago, my wife and I got a baby, so I don't sleep any much. But that's okay. First of all, a disclaimer. This is a work in progress. As was mentioned yesterday, we're still finishing some things in the framework. It's planned to be released in probably May, June, or something like that, so it's Q2. And the reason it's not public yet is because we still want to make the biggest wow effect we can. And there's also, we're paying a lot of attention to what I refer to the developer ergonomics, right? So we want to be, the default experience to be awesome. So there's things we may change over the course of the next weeks. So we'll do an overview of different features of the framework, and if I have time, I'll do a little demo at the end. So Micronaut, if I want you to get a couple of ideas about it, there will be two of them. So it's basically, on one hand, the productivity of something like Grails that you've been used to, and on the other hand, the performance, right? So take those two together, and that's Micronaut. It's a compile-time, non-blocking framework. It's been designed from scratch, from the ground up, with microservices in mind. It's very lightweight because it's based on Netty, so there's no serverless container at all. Built into the framework, there is an AOP and dependency injection mechanism for Java and Groovy and Kotlin as well, because why not? And as was mentioned yesterday, you can use Micronaut to build a HTTP client and an HTTP server. So this is about reactive microservices, and it's reactive because we embrace and support and allow you to use any reactive stream implementation. So you can use RxJava, Reactor, or Akka. Unlike other projects, like for instance in the Spring Boot 2, you're constrained to use a Reactor, but we allow you to use any reactive stream implementation. There's some cases where you can use also plain Java completable feature. So this is really small and fast. So for a hello world to be like the minimum piece you can run. You can get as low as 8 megabytes jar files. You can get as low as 7 megabytes of a heap size. And you've got there the comparisons from a hello world in Spring Boot plus Groovy or Grails. And the start time is really fast, so it's around a second. So features, let's begin with the dependency injection. So the dependency injection is inspired from Spring. This is one of the the design goals. So we want people to feel like at home. So we're not creating new concepts. So if you think of an object which is managed by the dependency injection container, we call that a bin, right? Like everybody else. So we're not inventing new terms. So it's inspired from Spring, but unlike Spring, Micronauts is compile time. So there's no reflection, no runtime proxies, no annotation metadata, etc. Right? The syntax or the annotations you can use are coming from the JSR 330. So it's everything under the Java X inject package, like add inject or add singleton, etc. And the way it works internally is implemented for Java, and Kotlin is implemented via something called APT. So it's an annotation processing tool. And in Groovy is done via AST transforms. So in both cases, what we do is to have a chance at compile time to generate new code, new bytecode in this case, right? Using the ASM library. So how do you use dependency injection? So there's a couple of things here. This works. So you first use the at singleton annotation to declare something which you want it to be a bin, right? Bins can be injected in other classes using the add inject annotation. That's all. You can use add inject annotation on setters, on properties, or on constructors. And in the specific case of a constructor, you don't have to use the add inject annotation at all. So this is implicit from Micronaut. Micronaut knows you've got a constructor here, and that's the dependency you're expecting, right? So it'll look for one in the application context and inject it to you automatically. So you can inject your bin types, or you can wrap them in things like an optional, or you can flag them as nullable, which is something similar. You can inject a list of your bins, a stream of them, a native array, etc. There's also the concept of bin qualifiers. So in this case, we've got a... can you see the code acceptable well? Yeah. So in this example, we have a V6 engine and a V8 engine, right? So those are both instances or bins that will be part of the application context. And whenever we want to inject this thing into a constructor, we can qualify which of the instances we want. In this case, what we're doing is saying, OK, I want an engine qualified by V8. And V8 is the prefix, right? We could do the same thing with annotation. So we could create an annotation called V8 with the at qualifier annotation. And then instead of using at named, we could use our own at V8 in this example. Another concept of the bins is that they are refreshable. Refreshable means they can be recreated in the application context at runtime, depending on several conditions. This is similar to the refresh scope in Spring Boot and Spring Cloud. But there's some differences. So in this case, we are annotating one bin. Instead of using at singleton, we are annotating it with at refreshable. Singleton is one of the scopes for a bin in the application context. And there's a special refresh scope for bins that are refreshable. In this particular implementation, we're using at post construct annotation to do something after the bin has been created. And well, this is a dummy implementation where we, let's say, calculate some value and store it as an attribute. So as you can see, the value is only calculated when the bin is created, and we may want to refresh that value, right? So then when we inject the service into a controller, the value we calculated in that string will be, let's say, fixed. So we can refresh the beans, which are refreshable, two ways. One is with a special refresh endpoint, right? We could make that's one of the production endpoints we are providing. That's a similar concept to the actuator endpoints from Spring Boot. So you could make a request to the refresh endpoint, or you could do it programmatically, making a call to the application content.publish event, and then you publish a refresh event. And then in this case, Micronaut will recreate the VM for you. So, but that's not the only thing you can do. So let's say you have a VM which depends on configuration values, like for instance, a MongoDB client, which depends on the MongoDB connection string, right? So you can say, all right, so this VM is refreshable upon any configuration change of any configuration property prefixed with MongoDB, right? So whenever there is a configuration change in the configuration system of any key starting with MongoDB, Micronaut will recreate the VM for you. So that means basically you can replace, you can change your configuration and your VM will be recreated automatically, which is really cool. What else? So we have the concept of a factory. A factory is just a class which produces beans. Simple as that. This would be a similar concept to a add configuration class in Spring Boot. So use the add factory annotation, and then you can have as many add bean annotations as you want. And you can, instead of going to the V8 engine class and then putting the add singleton in that class, you could do it here. Is the same. There's also the notion of a conditional beans, which means those beans will be created in the application context only if the conditions are met. So let's say you have a JDBC service implementation. There's actually here a book service interface, which we're not displaying. So there will be like a particular implementation using JDBC. But you only want to use this one if there is a data.URL property defined, right? So if that's not true, then the bean won't be created. Well, there's actually two conditions. So one is to require the data source class in the class path, and the other one is, well, actually, this is not to require a class in the class path. It requires to have a bean of that type in the application context. You can put as many as requires annotations as you want, and when you have like a few of them, it's nicer to group them into your own annotation, right? So we could create an annotation called requires JDBC, and then you put your particular, your individual that requires there. And then in your service, you just use yours, which is much nicer, as you can see. There are different conditions that you can use for your dependencies. Like, for instance, you could say that a particular class has to be on the class path, that a bean of a particular type has to be on the application context, that a environment property is defined, or there is a configuration class or package, in this case, available, which I will talk in a minute. You could require any Java or Micronaut version, or you could require any configuration property with any value you want. So when you have several configuration classes, there's a way to group them together So when you use at requires, you don't have to say, okay, I require this configuration and this other configuration and that. So let's say you have a package called com-example.json, and under that package you have singleton bins, you have factories, you have I don't know, configuration classes, so things that will become part of the application context. In any other place, you could say at requires, and then instead of specifying all the things you require individually, you require the whole package for you. So this is nicer because it's much shorter. You would do this in the package info class at the package level. Bin creation and destruction has a life cycle as many other frameworks. So we support the annotations of a JavaX annotation package like postconstruct, predestroy, etc. And there's also a way to do that programmatically. So there's a bin initialize event listener interface you could implement, a bin destroy event listener, etc. Right? Okay, next element, which is the application configuration. So we have the notion of a property source. And this is, again, a similar concept in Spring. So property source is a source of configuration properties, as the name implies. And properties can come from any of those places. And that's the order, actually, where they come from. So they could come from command line arguments, from the Spring application JSON environment variable, which is supported for Spring compatibility. Also, the Micronaut application JSON environment variable, Java system properties, operating system environment variables, and then we have the concept of a profile or environment, as you see here. So we support different formats for your configuration. We support properties, JSON, YAML, or Groovy, configuration formats, and there's two ways you could do. Like, for instance, you could say, all right, I have an application-development.yaml file, right? So whatever value you put there will only be available if the development profile is activated. And you can activate the profile the same way as in Spring with command line argument or environment automatically. So for instance, when you deploy a Micronaut application on AWS, we activate the AWS profile for you. So you could just drop an application-aws.properties, and those will be only read and made available to the application if the application is running on that profile. And there's a final place, like a global application file where you could put like global values. How do you read them? The basic way to read them is with the @value notation, right? So this is, again, the same as with Spring. We want you to feel like at home. But there's two things which are nicer here. One is the each property annotation. So let's say you have a configuration key, which is actually a list or an array of elements, like, for instance, data sources. So let's say you have myapp.datasources.1 property, and then myapp.datasources.2. With the each property annotation, what we are doing is creating a configuration class for each of the properties under that key, right? So this will produce two configuration properties with the two different values we have here. And then the next step will be for each bin. So we now have those configuration properties in the application context, and then we can say, all right, for each of them, what I want to do is to create a data source, right? So you see what I mean? So I've got a configuration, a data source configuration bin for the one data source, and I create a data source out of it, and I do the same for the number 2. So this is really useful. The small things, like for instance, typeset add configuration properties. The idea, and it's actually something we encourage you to do, is to encapsulate your configuration values in classes. You can do the same thing in Spring, of course, and the behavior is similar, but there's few differences as well. So in this example, let's say we have a engine config class. We annotate with the configuration properties, and the value we're passing is the configuration prefix. So basically, anything under my.engine will be mapped to this class for you, right? And this is a bin in the application context, so you can inject it. We'll see that later. There's also a nicer thing, that the properties are not only type safe. So for instance, the cylinder element is an integer. So you can't just say that's a string or anything like that. But it's also that this configuration class is validated. So we're using the bin validation API, right? So again, that's a standard from Java. So you can say, all right, this has to be non-blank. There has to be a minimum value of 1, and so on and so forth. And you can nest configuration values with nesting like other classes to map different elements. So the corresponding configuration for this class would be this one here, which is probably not the way to see it, but it's basically my, and then you have engine, and then you have a manufacturer, cylinders, crankshaft, etc. And then, as I said, those configuration properties are bins in the application context, so you can just inject them. Another example of implicit injection. This is important because we believe that constructor injection is a best practice, so we encourage you to do that, right? Although you could do it in a property or in a setter or something like that, but we believe doing it in a constructor is better. So the next thing is the AOP framework. That's a core piece of the framework because we need to support AOP for doing many things we do internally. And as many other AOP frameworks out there, we support 2 different advices. One is the around advice, and the around advice is basically to intercept any method call to any bin of the application context. The other one is the introduction advice. And the introduction advice is to create new behavior, like implementing a new class for you, like something like that, right? So the around advice is used internally in the framework for different things. Like, for instance, there is a trace logging advice that you could, will intercept things to trace method calls for you. The history support is implemented using an around advice. The cache abstraction, which is in the next slide, is implemented the same. As Graham mentioned yesterday, there is a circuit breaker implementation with a retry support. There's also one example here. The validation, the bin validation API is implemented the same way. And in the case of the introduction of advice, everything which is annotated with the add client is an introduction advice. It's important to understand that all the things you see here are compile time. So there's no runtime proxies, right? This is really important. So as I said, one of the examples you can see is the cache abstraction. So there's literally 3 annotations you could use, and is the same thing from, for instance, the cache Grails plugin you are probably using today. So there is a add cacheable, to cache values, cache put, to introduce element into the cache, and to cache invalidate to evict elements from the cache, right? And that's available today. The next item is the HTTP server. So there's two things you need for to run an HTTP server application. One is the typical application class, which in Groovy could be as simple as a Groovy script. So you just name it application, and you're done, right? You could a Micronaut.run. You could, of course, wrap this into a main method, but you're not required to do that if you don't want to. And then, for every endpoint or set of endpoints you want to suppose, you need to define controllers. So in this case, we have a hello controller, which is mapped to the root URL, and then we have an action. And we have a string hello, which takes a name, and in this case, the name is mapped to a path variable, as you can see. And this is checked, so there's no way for you to introduce typos, right? So if what you put here doesn't match anything here, you'll get an error. And also you can see we don't require you, unlike other frameworks, like for instance these pre and MVC annotations, we don't require you to clutter your definitions with add path variable, add parameter, things like that. So it's inferred from the names. How do you test this? It's very simple. That's what Graham showed you yesterday as well. First of all, an embedded server, right? So if this test is on the same package as the application class, then everything will just work. And there is a default HTTP client that you can create and use for making requests to your server. Although there's a better way to do this, but clients are non-blocking by default. But that's not going to work in a test, because if it's non-blocking, then your test will likely finish before the actual response has got a chance to come back. So you need to convert it to a blocking one. Then there's methods to make different HTTP requests. So this is using Spock. But you can do it using JUnit with Java, because why not? I mean, it's possible, and yeah. So it's actually, one of the design principles of Micronaut is that we don't want it to be constrained to anything in particular, right? So you could benefit from everything on the framework if you prefer to use Java. That's totally fine. Even the build system, right? So if for whatever reason it can't understand, you prefer to use Maven, you would be able to do so. So feel free, right? Routing, or routing, as the American says. So this is the two ways to do this. One is using the typical annotations I'm using here. As you could imagine, there's one annotation for each HTTP method, like get, post, put, delete, etc. There's more things you can say on an annotation. When you just pass a string, is the path they are mapping to. And there's more things you can specify, like, for instance, which content type is consuming that particular endpoint, which content type is producing, etc. Again, we have sensible defaults for your definitions. So those two actions are literally the same way. They are equivalent, right? Why? Because by default, if you don't specify anything, the method name becomes the URI, right? There's an alternative way to define roots, if you prefer so, and is using code. a big difference. So in Grails, you're probably used to the URL mappings file, right? In this case, with Micronaut, we are not using any custom DSL. The problem with the custom DSLs is that, first of all, in some cases, they are what is called stringly typed. It's based on strings, and it's easy to make typos somewhere. So if you misspell the controller name or the action name or things like that, things won't work, but you won't notice them, right? So in this case, we are using a compile static friendly API you can use. So there's basically any root builder being on the application context can contribute roots if you want. And well, there is a Groovy root builder which adds some syntax sugar to the root definitions, and well, that's the way to do that. You can read elements from the request from different places, body, cookies, headers, parameters, right? And there's special cases handled nicely, like for instance, optional element with Java 8 optional, or for instance, a date, which is this will be parsed using JavaScript's ISO whatever date format. And if you have a different format, you can specify so in the annotation. And there are some times where you prefer to use, like the low-level request and response. So one thing you have to be aware is that there's no servlet API here. So there's a request, of course, there's a response, but it's not a servlet HTTP request, right? So things might be different. In this case, for instance, we are getting the parameters manually, right? And then sending the HTTP response manually as well. We could pass the request in a reactive way. And how is that working? In this case, if you look at the previous example, well, actually we don't have any add body annotation. I've got examples later. In this one, we have an add body annotation, which is not put over a string, but it's put over a flowable. A flowable is an observable, right? It's an observable type from RxJava. This particular observable is one which has a back pressure control, right? So this is a hint for Micronaut to say, all right, I need to pass the request in a non-blocking manner, right? So it'll be done byte per byte for you, because you're declaring you want a flowable, you will be called with the flowable byte per byte. So here we are using the collect method from the flowable, and then we begin with an empty string buffer, and then for each byte we append it to the buffer. Once we've got them all, we do a response. So this is basically an echo implementation, right? The responses are similar. So the return type of your method will determine which type of processing you want. So if you're using any reactive type or completable feature, then Micronaut will handle that as a reactive response. But there's also the option to use non-reactive responses, like a plain string or a book or any POJO you have defined. And this leads us to the point to explain this threading model. So in a serverless container, this threading model is different from any native-based framework like Micronaut. So in Netty, there's one thing called the event loop. The event loop is the main processing thread pool. By default, I think it's 2 threads per CPU core you have. So you can think of it as something like 8 threads, 10 threads, or 12. So it's a relatively small thread pool. and is designed to be non-blocking, right? So whatever you execute there, it shouldn't block. So Micronaut, depending on the types you use, will use one thread pool or the other. And there is another larger thread pool called the IO thread pool, right? By default, this is configured to use an unbound thread pool, so it grows and shrinks as required. But you can configure that and say, all right, I want a fixed thread pool of 75 threads for the IO thread pool, right? We showed an example before of parsing like a string request in a reactive way, but we could do that using JSON. So we use JSON internally to convert from JSON to your classes, like in this case, a person. Again, we're using a reactive type. This is a single, so it's an observable that must emit one value, right? And again, this is a hint for Micronaut to parse the request using the JSON asynchronous parser. In this case, your flow will be called when the object has been read. But you need to understand that the JSON will be read in a non-blocking manner. So it's not like we're reading the whole JSON in memory and then sending it to you. No, it's doing non-blocking. And again, as I said, we could do that in a non-reactive if we prefer to, right? So instead of using a reactive type, we just use the class type directly. HTTP client. So given this controller, we could define a class with the add client annotation that will depend on the implementation of your service, right? As you can see, the annotations are the same. So this is a hint for you that it's actually a good practice and something we recommend to have the definitions on a single interface. And then you have your controller and your client to implement. To test it, it's very simple. You just have to fetch the bean from the application context, and you're done. You call method, and it'll just work. The features of the HTTP client we provide to you is service discovery aware. So you require services by service ID, and because services register themselves in the service discovery server, for instance, console, they say, all right, I'm the pet service, and I'm running on IP whatever, and port blah, 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 right? So you don't have to say which host and port are your services. You just specify the service ID, and the client will figure out where is it. If you have multiple instances of a given service ID, the calls will be load balanced automatically. The different strategies. So there's a default round robin. You can use Netflix ribbon, etc. It's reactive by default, right? So no call is made in a blocking way. It's also fault tolerant. So you could you can specify retry mechanisms, a fallback, even a secret breaker. By the way, there's another nice feature which I like, and is that with self-signed SSL certificates, it just works. You don't have to do anything, right? It just works, which is nice for testing against local hosts and things like that. The fallback mechanism is really simple. So you just define a fallback, and in this case, the bean annotated with fallback is implementing pet operations, which is the interface, right? So this client will, when you use this client to make a request to this endpoint, v1 pets, if it's throwing an exception, any error is not available, whatever, this fallback will be executed. You can use the Retryable annotation, so we can, for instance, say, all right, I want all the operations of this client to be retried 5 times with a delay of 5 milliseconds. And I can even use the secret breaker patterns. So I can say I want to retry 5 times with a delay of 5 milliseconds. And after that, if the service is throwing exceptions, I want to cache the exception and rethrow it for 300 milliseconds, right? To not overwhelm a service which is already failing. Another nice feature of the Retryable is that we can specify Retryable annotation with a given exception. So let's say you have a VIN which depends on a service to be available for it to be created. And this is something when you have multiple microservices, it's something you have to be aware of. So in this case, we're saying, all right, if there's any exception, well, if there's a service in available exception whenever we're trying to build a driver, let's retry, right? Serverless. So functions, we saw them yesterday. You can just create a Groovy script, and they will just work. You can also declare a function bin. This implements the Java util function package. So this is the input and the output. There is the concept of a function client. This function client is also the discovery service aware. So it'll work out where your function is running and will make a request for you, even in whether it is a local ISA service or in Amazon, Lambda, wherever. We'll figure out. You can tell your function like instantiating the object directly and making a method call. That's at the unit test level. You could run an HTTP server, an embedded server with your function, and use your function client to test them. Or you can test them in AWS Lambda directly with the same client, right? So as you can see, there's a little setup to test your functions. And the last thing I wanted to talk to you about is the Petstore. So the Petstore, let me make this, try to make this bigger. So this is a showcase of all the things you can do with the framework. This will be published along with the project, right? So we have a front end built in React. There is let's call a facade for that front end written in Groovy. We use console for all the discovery services. There is an API module with Java interfaces that all the client and servers are implementing, right? So those are shared. And those, those are the different backends. We've got different implementations as a showcase. Consider this as a showroom where we show you examples of how to do different things. So there's no particular reasons where we choose Java Groovy, so it doesn't matter. So we have a module with a relational database, Redis, Neo4j, Amazon Lambda, Amazon. This one, for instance, is one of the examples of a conditional profile. So the email service written in Java has got 2 different service providers in this case. So it could send them emails through SendGrid or through Amazon. So if this service is deployed on Amazon, it will choose the Amazon one for you. I have 3 minutes or something like that to show you something, which I will try to do. It's a little bit big. si lo que está intentando hacer. Ah, vale, mejor. Okay, so there is an event stream here we have, as you can see. Is a server sent events request from the front end, and that's going all the way through, the front end, which is everything in React, to the storefront, which is the facade, and the storefront is delegating the code to one of the backends, which is retrieving information from the actual data source, which in this case is Redis. So if we were going to look at the code, we have, first of all, I'm a little bit out of time, but I hope you can forgive me for that, because this is really cool, right? So the first entry point is the store controller. And this is an action where we're using an event stream as a response, right? This is what we produce. And as you can see, it's a flowable of events. As I told you, the service is a facade for the different backends. And we are using this guy is a RX stream in HTTP client. So it's an HTTP client using RX Java, which is server-sent events aware, right? So we'll make a request to the backend, we map it to an offer class, and we send back an event to the client using that offer object. And the actual implementation is in the offers. So where are you? This is the one, right? We get a random offer from the repository, which is Redis in this case, repeat it hundreds of times, and emit them with a delay of, by default, 3 seconds, right? That's what we're doing. So you can see this is very few lines of code. The offer repository is just a just using the lettuce driver from Redis, right? So this is just the actual implementation of fetching an element from Redis, which is not part of the example I want you to make. The other thing I want to show is history support. So we have the ability to we allow you to use history commands, right? So history commands are the Netflix implementation of a secret breaker pattern, and there's also a dashboard you can use for that. So this service has got 2 history commands that you can monitor, and you enable histories like with a configuration value there, which is a history stream enabled. So there is a dashboard here with the 2 different commands we implemented. So what I'm going to do is to throw some load on it so you can see how it is working. 1 minute, okay. Right, so we're making requests to these history commands, and we can see how fast this is working. So I could do something like, for instance, I could make the implementation to throw any error, and you will see that the circuit will get open, right? So whenever this is going to fail, the circuit will be open. And 2 more things. Well, this console support, so all these services register themselves on console. If you have enabled that. And the small things I couldn't explain, as you can imagine, but for instance, the degradation you showed yesterday on the Petstore frontend, like for instance, if we shut down the comments application, you don't see the comment section happening. That's because we also have things like the actuator endpoints from Spring Boot, a similar concept, right? So we've got health endpoints, info endpoints, environment endpoints to display the environment configuration, right? So we've got you covered. And yeah, so that's it from me. I don't know if there's any question. Yeah, there's a couple of two.
What about security? We can't use Spring security for it?
No, at the moment you can't. There's no reason for us to not support it. So at the moment, one thing you can do, so one thing I didn't mention is the concept of filters. So the framework has the concept of filters. So that could be implemented by you because, Spring Security is a filter-based framework. It is in our roadmap to provide a JWT authentication mechanism for you, right? Because Spring Security is not a simple project to integrate, right? It's stateful, it's based on Spring, and introducing Spring in a Micronaut project will make the thing less appealing because you're introducing all the runtime things of Spring, and it may not be desirable. So we may look at other solutions like Pack4j or things like that. So that's still in the roadmap.
I'm trying to figure out something. You're saying, of course, obviously you can use alternatives for different environments, but at the same time you're saying that everything is every dependency is injected at compile time. So when you're adding a dependency that depends on environment, do you have to provide this environment variable at compile time, or so you have to create artifacts for different environments? How does this work?
No, so the value is obviously read when the application starts, right? Is the ability to inject the value for you, what is done at compile time. But to activate a profile, you have to do that at startup time. So there's no way, you don't compile your application for a particular profile. There's a question over there.
Last question.
Come on, Ivan.
No. We need a schedule.
This is really cool. Let people to ask questions.
Thank you for the presentation. I have a couple of questions. First, you showed that there are support of free frameworks for reactive functionality.
Yep.
How is it's actually to change the usage of another framework like ECA and your controller, for example, instead of this single classes and so. And the second question, do you have any view layer like JSON view, for example, in Rails there?
Not currently.
No?
So there's no.
Okay,
we believe. I mean, there's no particular reason to not integrate it in the future. I don't think it's going to be part of 1.0. Graham is over here, so maybe he can clarify. And the first question is if you can use any other reactive stream implementation, and the answer is yes, you can.
So for the reactive, basically we implement some type of reactive streams. So whatever implementation implements reactive streams, we support. So if you can return ACA objects if they implement the reactive streams API. You can return Reactor or RxJava, and we have even RxJava 1 adapters for if you're using RxJava 1. Yes, yes. As long as it implements the reactive streams interfaces. And then on the view side of things, we do have it on the roadmap to add support for JSON views and maybe other view technologies. But since Micronaut is primarily designed around JSON microservice interchange in terms of remote calls and so forth, it's not an immediate priority But you know, as folks, I know a lot of folks like JSON views, and there's no reason why we can't add support for it. So that'll come further down the line.
Thank you very much.